This version of my compass motor uses a NEMA17. It's a thin 23 millimeter form factor NEMA17 stepper motor. And the top speed I could get it to go at with the load on it of the magnets on top was 60 RPM, which you're seeing right now. So I was hoping to get it to go much faster. I'm using 12-volt batteries. I'm using eight AAA batteries, 8 AAA batteries, and instead of the 9-volt battery. And the top speed I can get out of it when the batteries are brand new fresh is 60 RPM. I tried starting at 150 RPM, it wouldn't turn at all. 100 RPM, it would turn like an eighth of a turn. And then when I got down to 60, it would go. So maybe it will go at 70 RPM, I don't know. But it's doing 60 RPM, and I verified that by running it in slow motion. So I'm going to go on with this video and continue to talk about how it works, and it's going to run much slower after this. So it'll do 35 RPM for a little while with the batteries run down. It'll do 20 RPM for like 10 minutes. What happens is it doesn't make it all the way around 180 degrees. So the motor gets kind of flaky with not enough voltage. And it could also be the L298 controller that gets hot. So if that overheats, that could get flaky too. The motor doesn't get very hot. The motor gets a tiny bit warm. The batteries get a tiny bit warm. These are AAA batteries. So I don't know, it's good. But I'd like to see it go much faster, but this is the best I could do with this stepper motor. So I got it to go 60 RPM, and I did verify that it was doing 60 RPM. So now it's doing about 35 RPM. So if you don't understand, these red tubes that you see on the side, these are shrink wrap around LDRs, light dependent resistors. And when the light dependent resistor passes the light, it activates the motor to turn the motor on for 180 degrees. And there's a toggle in the program, so it can only activate alternate sides. There's 2 LDRs, so after it activates one, it can't activate that one again until it activates the other one. So that eliminates the need for any debouncing. And it also prevents it from getting stuck and just having the motor spin around. So yeah, it's going kind of nice. Let's see if it runs a few minutes. So you see the magnet is pointing a little northwest. If you're looking through the camera at the compass motor, you're basically north of the compass motor, and this end with the red lines on it is the north end of the magnets. So there's 2 columns of magnets in there, 2 stacks of magnets. They're 3/4 inch N52 neodymium magnets. So they're very powerful. And I had that special 3D printed to contain them. The motor itself adds a lot of weight. The motor weighs about 4 5/8 ounces. And there's some extra wires involved. And the extra batteries weigh more too than one 9-volt battery. I originally tried one 9-volt battery and it just wouldn't work. The motor turned fine with no load. So the 9-volt battery worked great with no load. But as soon as I put the magnets on, the magnets weigh about like 5 or 6 ounces, maybe more. And as soon as I put them on, the load was too much for the motor to turn. But the motor has a lot of torque. If you use a 9-volt battery and you try and hold the motor still while it turns, it's very difficult to stop it. So you see there's LEDs here. You can see the LED come around and turn red right here. It's blue and then it turns red. I don't know if you can see that. So it runs nice at 35 RPM. So that's a setting you put the stepper motor at. The stepper motor has 200 steps per revolution. So there's a special Arduino stepper library. And it's a very simple program. You just use the example they give you. And all I have is 2 if clauses. And so it's like if the light hits one LEDR, then turn on the light, the LED, and turn the motor. And then that's it. And then there's another if clause that does the exact same thing for the other LED and the same thing for the motor. So that's running pretty nice now. So I had hoped to get it up to like 200 RPM. I wonder if I put like 4 more batteries, if it would go much faster. It's kind of asking a lot from that L298 controller. It does get kind of hot. So it's a 1 amp. It's a 1 amp stepper motor, 12 volts, 1 amp, but it's 12 to 24 volts. And I'm sure it's not getting quite up to 1 amp. But it's supposedly 3.7 ohms on the windings. So by my calculation, that's like 3.2 amps for a 12 volt batteries going through it. And it's not doing that, that's for sure, because that L298 would never handle 3.2 amps. The most it can handle is 2 amps and it'll shut down. So yeah, that's my latest accomplishment. So let me know what you think in the comments. And if you're interested in learning how to use a stepper motor, it's really, really simple. But you got to try it to find out how fast it can go and how powerful it is. So I'm wondering if a bigger motor might make it faster. But I see guys get the stepper motors up to like 4,000 RPM, but they're using like 70 volts and like 6.5 amps. So I'm never going to get that out of batteries. But I could consider using lithium-ion batteries or LiPo batteries like they use in quadcopters. Those might be much lighter and have more power. So if I had like 6 of those batteries, 6 3.7 volt batteries connected together, that might work better. But right now I'm kind of happy with this, but it's not going to break any records for speed. So yeah, that's it. So I'm going to turn it off now and maybe run it later. And you see when I turn the light out, it turns off and it's going to come around and point north. And swing back and forth a couple of times. These are good bearings. This is a swivel bearing up here. I don't know if you can see it. It's it worked out nice. It's a nickel plated ball bearing, I think it's called a snap lock, or some kind of lock, swivel, and it's very good. So yeah, so let me turn out the power. And thanks for watching. Like, subscribe, and give me a rumble.